Alright, it's time for the solutions for the pre-assessment benchmark 3. So it's basically a study guide for benchmark 3. So yeah, let's jump right in. So number 1, what's the precise definition for angle? What I recommend for this is, as you read through these, draw what it looks like. So right here, we have two lines across, meter angle. Hey, those are perpendicular lines. On B, we have two rays with a common endpoint called a vertex, where we have some vertex and two rays going off of it. Hey, that's an angle. Ta-da! It's B. I do want to point out some of the rest of these, though. Part of a line that consists of two endpoints. So here's a line. We got a couple of points on it, and all the points in between. Hey, that's a line segment. And then D, we have something called a center, and it's talking about all the points that are equidistant, as in the same distance away. Hey, that makes a circle. So there you go. That's what we're trying to get at with these. So we have circles and all that. Number 2, transformation that takes point x, y to point x plus 3, y minus 3. So if you're adding 3 to all your x's, you're going to be moving your shape to the right 3. And if you subtract 5 from all your y's, your figure's going to go down 5. So this is a translation. Right 3 and down 5 units. On number 3, which is following, changes the height of a rectangle but not the width. So if we have a rectangle here and we want another one that has the same width but a different height, that would be a vertical change. It would be a vertical stretch, because a shift just moves it. A stretch is actually changing the size. On 4, the line of symmetry for the figure. Well, that one doesn't make equal triangles on both sides. That doesn't even make, that side's a lot smaller than the other one. And then on B, the top side is smaller than the bottom one. The only one that works is C, that middle line there. 5, which of the following counterclockwise rotations carry it on to itself? Well, if you do a 90-degree counterclockwise, it's going to look like this. If you do a 180, it's going to look like this. And if you do a 270, it's going to look like this. It looks like we're going to have to go all the way around, which would be 360 degrees. On 6, transformation carry figure 1 and figure 2. So they notice this long peak out here is matching up on the other side. So we're not looking at a rotation here, but rather a reflection. So this would be a reflection over the y-axis, which is that axis in the middle right there. 7, which of the following show the figure rotated counterclockwise 90 degrees? Well, counterclockwise is this way, and 90 degrees is a quarter turn, or turning 1/4 of the way around, and that's going to put it right here in the second quadrant, which is B. Let's move on to 8. So on this one, with relationship C, undergoes a series of rigid motions. And that's important to know what that means. That's those are translations, reflections, and rotations. And so if you do one of those 3 things, do your side lengths change? Do your angle measurements change? Do the angles change how big they are? The answer to both of is no. They stay the same. So they are congruent to each other when you do one of those 3 transformations. So the answer is going to be A. On 9, we need 2 rigid transformations that can be used to prove ABC is congruent to DF. So we're going to take this guy and move it over and get it to land on the one down there. And I'm going to go with that first one there that I kind of drew out, which is going to be a translation. And I'm going to have to go left 1, 2, 3, 4, 5, 6, 7, 8. Translation left 8 units. And once I have that, I would then just need to reflect it over, because it would be up here, and things like that. Anyway, just reflect it over, and then I'll get it to match up. So that's going to be reflect over the x-axis. Moving on to 10, which side on the one over here corresponds to BC, which is right here, which is the medium-sized length, and the one over here, that's the medium-sized length, this is DE, or ED. 11, which of these is not a way of proving triangle congruency? Well, these are the ones that we use. We spent a couple weeks on all this stuff. These ones, yes, prove congruence. This one is a no, and that one's the one that we exclude. You can also, there's one other one that does not prove congruency, and that's side-side angle. And at least not doesn't always guarantee congruence. So I gotta keep that in mind. Side-side angle's the other one. 12. Which triangle congruence can be used to prove triangles are congruent? Well, right here in the middle, we can add some vertical, those are vertical angles, so we can add some congruence marks. And now we have two sides and the angle that's between them on both triangles, two sides, angle between them. So we have side, angle, side for both of our triangles. 13, what additional information in order to get angle, angle, side? Well, here's the two angles that we have. They're BC and HG. So we don't want those sides. Any sides except those ones. So that'd be FG and AB. And those can match up. AB. Or we can get the other ones to match up, which is HF and AC. Or FH to AC. So those are the ones that can match up, and we'll be good to go. 14, slope of the line segment is that. What's the slope of the line of symmetry? So if I wanted to draw a line that would make it so when I reflect over it, those match up, it would have to be a perpendicular line, which I'm having a really hard time drawing. Okay, it's going to go through the center, and it's going to be, there we go. So there's a perpendicular line, and you just need to get the slope of that line. Well, you start here, and you go over here, or you end up here. That's a rise of 3 and a run of 1, which is going to give you 3. And if you happen to know that in order to have, for the two lines, in order for them to be perpendicular, they have to have opposite reciprocal slopes. You can turn it upside down, change the sign on it, and it's also 3. So 3 is the answer, slope of 3. And then 15, given angle PQR, what construction was performed? Well, look at the thing. We started out with an angle right here, and we didn't copy it. There's not like another one over here. Instead, we have this line in the middle, which cuts it in half. That makes it an angle bisector. Remember, cutting in half is to bisect. And so that's the end of the regular questions. The other one, the next questions deal with honors topics, except for the last two. Those are the last two that everyone needs to be aware of as well. So jump to the last two if you're curious about those. 16. Vector quantities have both direction, direction, and magnitude. So think about vector on Despicable Me if you've forgotten things about vectors, direction, and magnitude. What's the magnitude of the vector? Well, here we have a vector. In order to get the magnitude, you're going to take both of those numbers, square them, add those results together, and then square root. Negative 3 squared is 9, 5 squared is 25 when you add those, and that's going to give me the square root of 34. And we're just going to leave it just like that. 18, which is correct component form. Well, if you start out here at 5, -7, you end up at -6, 8. In order to get component form, you take these numbers and you subtract those ones. So if I take -6 and -5, and then I take 8 and minus -7, I get my components from my vector, which comes out to be -11, and then 15. And that gives the A. -11, 15. That should be a 5. There we go. 19. Suppose the plane's traveling 145 miles an hour west, so that's going to be this way. That's going to be 145. And then going north, there's wind blowing north at 30 miles per hour. And so if I were to combine those together to make a vector, that'd be negative 45, positive 30, because I think west is a negative direction, and then north is a positive direction, so negative 145, 30. We need to get the resulting speed and the nearest whole number. Well, you just need to square both those numbers, add that result, add that to each other, and then square root. And if you do that, you're getting approximately 148 miles per hour. And that brings us to 20. We have these two vectors here. We need to subtract them. So order matters on this. Make sure you do C minus V. And that's going to be negative 7 minus 4, comma, 4 minus negative 1. So anyway, that gives us that. Negative 7 minus 4 is negative 11. 4 minus negative 1, same thing as 4 plus 1, which is 5. And we have negative 11, 5. If we're given that the magnitude of some vector m is 13, and we multiply it by a negative 5, what would be the resulting magnitude? Well, remember, we actually did this, and we had this sort of question on our vector operations assignment. If you take a vector's magnitude, and you times by some scalar, it's going to be equal to, it's going to be that, but the absolute value of it, because magnitude's always positive. So really, if you just take 13 and you times by 5, you're going to get how much that is. So 13 times 5 gives me 65. There we go. It brings us to 22. Here's my vector. Find the rotated vector using that. So I'm really just taking this this here and multiplying by the matrix right there. So that's like having 7, negative 2 multiplying through, and that's going to give me 7 times 5, which is 35, and then negative 2 times 0, which is 0, add that. So you get 35 to start out with, and then I can do 7 times the 0, and then negative 2 times the negative 5, add that up, that gives me positive 10, and that's it. Ta-da! And then 23, use determinants to find the area of the triangle of the vertices. You're going to take these vertices and put them into a matrix where each coordinate, each ordered pair is the row, and then you have one column of ones here on the right side. And once you have that, you're going to get the determinant of that, find the absolute value of that, making it positive, and then times by 1/2, and that'll give you the area, which, hold on. Alright, yeah, if you do that and you divide by 2 or times by 1/2, you get 49, and that's going to be, some sort of units squared. Anyway, so there's the vector stuff. Alright, and now on to the constructor response part. So if you're going to do a perpendicular bisector, that's where you put your compass on one end, and you pick some hole that goes more than halfway, and you draw an arc. And you have to remember which hole you use, because you're going to take your compass, put it on the other side, and use that same hole to draw the same arc, but center it on the other side. You're going to get 2 overlapping arcs like this, and then you're going to take your straight edge, and you draw the line that goes through those intersection points, and that is a perpendicular bisector. And the last one, you're supposed to draw a regular hexagon constructed in a circle. To start out, you're going to put a point on the edge, put your compass there, figure out what hole gives you the center, and then use that to draw a line that goes to the edge. And you can keep doing that all the way around. And of course, I always make these way too far apart. 1, 2, 3, 4. Okay, there we go. Now I got it, and you connect that up. And if you did it correctly, you'll get a regular hexagon, which will look a lot better than this one. And there you go.